All right, here we go. That was number 1. I'm going to go over number 2, number 3, nice and slow, and then 4 and 5 we'll read the answers. I didn't do them, but I'm hoping you guys did, and we can come to a consensus there. All right, and then we'll talk about the worksheet due Friday, and then look at the review sheet a little bit. All right. Oh, by the way, wasn't that due today?
Yes, sir.
Nuclear charge. Who remembered to look it up? Raise your hand. Be honest with me. Okay. Before I get into the rest of this homework, let's real quick talk about that. We probably won't get into that until Friday. Matt Payne, what's nuclear charge?
Total charge of all the protons in the nucleus.
Very good. Inside every atom in the world, all the atoms that make you up, all the atoms that make this desk up, the atoms that make this marker up, the atoms that make up, I don't know if it's my favorite fruit, maybe an apple, but anyways, it's a good fruit. All the atoms that make up the banana. Every single atom in the universe. Every single atom in the universe. I'll never get tired of that, I guess. The nucleus is positively charged. There are two parts to the nucleus, to the atom. 2 parts to the atom. Little tiny nucleus, and then outside the nucleus. That's the only 2 parts. So atoms kind of look like this. You have a little tiny nucleus, and you have this weird invisible boundary. It kind of looks like a sphere. We think of atoms like little marbles. Inside this tiny nucleus, there are protons and neutrons. Protons are positively charged. So the nuclear charge is the positive charge due to the protons. Very good definition. And if you look on the periodic table, what number tells us the protons? The atomic number over there happens to be the blue one. Okay? So we're headed towards that. We got finish up today with this heat stuff, table I, and that's a new unit. Question?
Oh, my question was, isn't it the same as the atomic number?
Yes, the atomic number tells you the nuclear charge. Yes, it does. Yep. Okay? And again, the word nuclear means nucleus, charge means positive, negative, neutral, and it's always positive. Okay? Atom is always positive with his nucleus. All right. 2. H2 plus I2 yields 2HI. This is the friendly reaction. No one's got anything for me there? Huh? It's a really bad joke. It's a friendly reaction.
Oh, hi.
It says hi. All right.
I
Come on, you guys got it.
noticed
You guys didn't even follow me there. Either you thought it was too stupid or you didn't understand what I was saying. Maybe a little bit of both. All right. All right, so HI is your product. So hydrogen iodide or hydroiodic acid. So how many moles of H2 do we have? How many moles of H2?
1.
1. There's a 1 in front. I need everyone to kind of recite this here out loud. How many moles of I2? 1. How many moles of HI? 2. The numbers in front, they're called coefficients, are the number of moles. It's really important to remember that the rest of the year. Okay, Courtney, what's the mole ratio between I2 and HI?
1 to 2.
Very good, 1 to 2. Ariel, what's the mole ratio between HI and H2?
1 to 2.
Try again. From HI to H2. Try again. I'm confusing you, but it's the way I'm wording it. So the ratio of I2 to HI is 1 to 2. What's HI to H2? 2 to 1. And it's important, the order, even though she understands. Okay, I just confused her. It's important on Regents, if they ask you a specific order, make sure you write the specific order. So it's 2 to 1 because this was first in the question. I know that's annoying, but just pay attention to the wording on those types of questions. All right, anyways, who could tell me? What's the value of delta H on table I? About Tyler?
53.
Positive?
Positive.
Make sure we write that. Exactly 53?
Exactly.
All right, 53.0 kilojoules. All right, here's the question. It says, calculate the value of delta H if 2.5 moles of I2 react. So we have, here's our proportion, right? We have 1 mole that needs, this is endo, it's absorbing, it needs 53 kilojoules, right? So here's our I2, here's our kilojoules. We know 1 mole needs 53. The question is asking or telling you what is the value of delta H. So that's here. Delta H is on the bottom. If 2.5 moles of I2 react. Notice how I keep moles on top, delta H on the bottom. All right? I'm not a big stickler as far as you have to do things my way. That's not how I am really with anything. However, with this, I really suggest you do the same thing as me. Moles on top, delta H on the bottom. Moles on top, delta H on the bottom. So we're all consistent. Okay? So 1 over 53 equals 2.5 over x. Cross multiply 53 times 2.5. Who has that answer? 132.5 kilojoules. Can anyone confirm that? Yep. Okay, good. So, and it's positive. Make sure if it's positive, you write positive. If it's negative, you write negative. It makes sense. If we are reacting more moles, you're going to need more heat. It's a proportion. If one goes up, the other goes up. Questions? I'm going through it very slow on purpose because you're actually using a lot of knowledge here that we're going to need down the road. So we're just going to learn it this time, and then when we get there again, you don't have to relearn anything. So I didn't give you any chance there for questions. Questions? Okay. Number 3. I'm going to speed it up a little bit here. I want to make sure we have time. Okay, so for number 3, we got 2CO plus O2 yields 2CO2. If it's 0.25 moles of CO2, all right, so for number 3, this is what I'm doing. So my CO2 has a 2 in front of it. That goes on top. Who can tell me what's the value of delta H for number 3? Colin.
Negative 566.0.
Negative 566.0. So this is 2 moles of CO2. Here's my kilojoules. That's from the balanced equation. This is from table I. This right here, nothing that I came up with on my own. The 2 is in front of CO2, and that's on table I. So now the question says, calculate the value of delta H if 0.25 moles of CO2 are used. So if 2 moles are produced, this is how much heat is released, exothermic. If 0.25 moles are produced, what do you think? Should this number go down or go up? Down. You should have smaller amount of heat released. What's that? Well, the negative sign is just telling us it's released. So the actual number will be smaller. So it'll be a smaller number than 566. Cross multiply, 0.25 times 566 divided by 2. What do we get?
Negative 70.75.
70.75? Negative 70.75. That makes sense. Okay? That makes sense. It should go down because there's much less moles being produced. It's a proportion. If one goes up, the other goes up. One goes down, the other goes down. All right, number 4. I didn't calculate the answer. I'll write it down though. What do you guys think here? Nicole, what'd you get for 4? 124.45?
Yeah.
Positive or negative? Positive. Anyone else agree with that?
Yeah.
Okay, good. Positive 124.45 kilojoules. Number 5. Adam, what'd you get?
1,664.2.
Positive or negative?
Positive.
Positive. Do we have confirmation on that number?
No.
Oh boy. All right, Adam.
I got negative.
All right, we'll do that quick here. So if you look at number 5, we're dealing with O2, which has a 5 in front of it. So we have 5 over, what is the value, Adam, on delta, or on table I of delta H?
Negative 2,219.2.
You got table I open?
Yep.
Okay, well, look that one up again. I know there's none on there that big.
I put that too.
Yeah, I put that. It's the second one.
It's the second one.
Nonsense.
There's one bigger.
Sense, man.
Right there.
All right, just kidding. Just checking with you, Adam. Negative 2219 what? 2. Sorry, Adam. All right, so now if you go to O2 in the question, it says 3.5. So instead of 5, we got 3.75, and then X. So is this what you did? Something like that?
Yep.
And that's not right? Negative or positive? Oh, it can't be positive. You mean negative. Right? Your answer's got to be negative because this is negative.
I got
Oh, yeah, okay.
0.4.
That's what I got.
Yeah, I got 0.4.
I got the same number as him, but
Negative 1664.4.
yeah.
All right, that's pretty close. I still give it to him. All right, so I don't know what happened there. All right, so negative 1664.4. All right, so here's the deal. I thought you were going to raise your hand. Here's the deal. can you set up a proportion and can you read the question appropriately? In other words, if they give you the balanced equation, are you able to plug in the numbers in the correct spot? Moles on top, delta H on the bottom. Moles on top, delta H on the bottom. That's how we do these problems. There is one of these on your tests. I'll probably make it a bonus question because we're just kind of doing it now, and that's not really fair to just give it to you the next day. So there is one of these, and I'll make it a bonus question. But, you know, you want to get that bonus right. So this is how you're going to do that. Okay, put that away. Now go to, keep everything else out, your reference tables, the worksheet I gave you due Friday. Let's go to the front of that. Okay, let's kind of look at that. It's kind of like notes. So I'm not really going to give you a whole lot of notes. We're just going to do a practice problem. And then on the back of this is the homework due Friday. So if we look at the front of that worksheet, look at the front of that worksheet, it says, I'm just going to read it to you and then see if this makes some sense. When looking up an equation on table I, it's important to know if it's exo or endo. Positive is endo, negative is exo. I'm going to skip through that, you know that. However, there are two rules for representing the value of delta H in a chemical equation when the reaction is written out. Two rules are, if the reaction is endothermic, the value of delta H is written with the reactants. If the reaction is exothermic, the value of delta H is written with the products. For example, if you look at the very first reaction on table I, so go to table I, look at the very first reaction. And make sure you're on table I with me. Okay, if you look all the way to the right, Trevor, what do you see for the value of delta H?
Negative 890.4.
Negative 890.4. Okay, now look at the worksheet in front of you. When you write out a chemical reaction, sometimes you are asked to put the heat in the actual equation. If it is a negative value, meaning exothermic, you put the number on the product side. So if you look at that reaction written in front of you, the 890.4 is on the product side. What's the problem students always have with that?
They put it as a minus.
Where'd the negative go, right? If you look right here, look up here. If you look here, there's no negative, right? So when you write these in the equation, so CH4 plus O2 yields CO2 plus H2O, and I think we need 2 and 2, right? Two of these. This here, 890.4, 890.4, what this actually means, the value of that is actually a negative number. That's the confusing part for students. I understand that's confusing, so I really just ask that you try and memorize this. That when you see the energy on the right side, the product side, that means exothermic. And the way I explain that, usually it makes sense to students, I think. At the end of the class, what do you guys do? Leave, you exit, you go out of the room. Reactions are the same way. At the end of the reaction, the heat will leave, the heat will exit. So if that analogy helps you, I hope it does, then that's good. If not, then I guess you just memorize it. But at the end of the reaction is when energy leaves, it exits. Same thing here. So if you see it on the right side, it really does have a minus sign. The reason there's no minus sign here is when you write chemical equations, you don't put minus signs anywhere in the reaction. It's just kind of a rule. And the other way to explain that, these are not plus signs. What do they really represent? They're not plus signs. You're not adding these together. It just means they're reacting together. It just means they're together in the reaction. It doesn't mean like addition in math. Okay? So you're not literally adding these, all right? They're just reacting. You're not adding these, just means they're products together on this side. So this is not being added, all right? It's just part of the products. That's what that means. So it's confusing, I know that. So that's exothermic. If you see a minus sign on the delta H, this is how you represent it in the equation. You put it on the product side. Again, at the end of the reaction, at the end of class, that's when you leave. That's when you exit. So that's the same thing in chemistry. Now, if it's a positive number, so keep looking at the worksheet there, reading further down, it says, according to the table, so I just explained that little paragraph there, okay? According to Trevor's table I, N2 plus O2, so we have N2 plus O2 yields 2NO. So if you find that reaction on table I, so scan down until you find that. I don't know, it's somewhere near the middle, I believe.
It's 66.4.
No, it's 182.6.
Oh,
Find that
okay.
one. 182.6. It's not that crucial that you find it right now. It's written on the worksheet. But if it's positive, what does that mean, Mike? Endothermic. So if you go back to the worksheet now, look at the example. Now the energy goes on this side. 182.6 kilojoules goes here. So if the value of delta H is positive 182.6, it goes on the reactant side. What does positive energy mean? What's it mean? Endo or exo?
Endo.
Endo. It's absorbing. Look up here. Every single endothermic reaction in the world will never react without gaining heat first. It needs that energy to get going. It's the opposite of exothermic. Exothermic doesn't need heat to get going. It needs to lose it to finish. That's kind of how that works. This type of reaction, these two, if they don't gain this energy, they will never form the product. Never form the product. So that's why endo goes on the left. So if it's a positive delta H, you always write it on the left side. Why? Because it's absorbing in the beginning. Or entering. When you come into class, in the beginning of class. When does the energy enter? In the beginning, right? Entering, absorbing, that's the analogy there. Exiting, leaving, that would be on the right. That's exothermic. So I try and say these things to help kind of, I don't know, send something in your brain that helps you remember this. But endothermic will go on the left because it needs it to start reacting. So I can give you all the tricks that I think work, but really it comes down to you just got to remember this. I don't like saying that sometimes, but if you can just remember exothermic's on the right, endothermic's on the left, you'll be good to go. Okay? So on the back, what you're doing, due Friday, is you're counting, you know, whatever, the 7th, the 11th, 4th, so just count from the top of table I. Okay, so count. All right, well, however I worded it, yeah. So count, get to the reaction, write the reaction down on the line, and then you are putting the delta H on the appropriate side of the equation. So if the 7th reaction is endothermic, you're putting it here. If it's exothermic, you're going to put it over here. So it's just practice of what we're showing here, okay? That's what you're doing on the back. Anyone confused with what you're supposed to do on here? So, that's it for the heat stuff. We're actually done with this unit. It's a real long unit. We started it back in September, believe it or not. And Friday, after the test, because we have a little bit to do Friday as well, we'll get into that nuclear stuff and atomic structure. I didn't get to the review sheet, but that's okay. You have it. Go through that review sheet, please. Okay, I want to see good grades on this test. All right, so go through that review sheet. And that's it. Bell's gonna ring real soon. Good work today. Maybe we'll see Morgan tomorrow. Hopefully she watches this, and that would be